So let us look at lambda functions now that we're familiar with functions. A lambda function is a small anonymous function, so it does not have any name and it is written only in one line. A lambda function can take any number of arguments, but it has only one expression. So this is how we declare a lambda function. So let us look at that in Jupyter Notebook. X is equal to lambda is the keyword. So now we can write the lambda function. So a and b and a star, or let us say a plus b here. This is the add function. So we've written the add function here. So it took us like d e f add a plus b and then this indentation. The same thing we can write it in lambda function in a shorter way, where we are passing a and b and it will return a plus b. So whatever we return as the output will be here as a plus b, and we can whatever we want to pass will be a comma b, which will be before the before the colon. So this is how lambda functions are written. So they are just one line functions. They help us a lot when we want to use maps or filters or anything. So let us consider a scenario for that. Suppose we want to have strings. Let us consider strings. So we want to have strings of apple, banana, and mango. Okay. Okay. So let us give the return type of a plus. So we have the a plus b. So now let me give print x and let me pass 2 and 2 into it. So we are passing 2 and 2, and we are calling this function using x. So when 2 and 2 is passed, so x is equals to 2 plus 2. So that is how this will be executed. So now let us look at how we can use these things. So for example, if I have strings over here, which is apple, banana, mango, we have sorted strings which will be sorted based on their length. Here we can use lambda function. So we want to use this function where we have x. So each of these x, which is apple, banana, mango, will be passed, and according to their length they will be sorted. So when we print sorted strings, we get apple, mango, and banana. So this is how they are sorted according to their length. So this is how we can use lambda functions. So let us consider another scenario. You might not be familiar with maps, but let us take a scenario for map. Map is used when we want to have when map is used for applying a function on all element of lists. So for example, if we have a list where we say nums equal to 10, 20, and 30, and we want to have a function called square, right, which will return the square of each of the square of a number. So when we have n passed into it, this function will return n star star 2. So this will return the square of n. Now if we want to execute a square function for each of these elements, we will have to write a for loop. Instead of that, we can use a map where I can say square and I can pass nums into it. We get the, when I say map of nums, I get the address again. So let me typecast it into a list. Here we get 100, 400, and 900, which are the squares of this. So here I'm passing a function, I'm calling a function here square, and I'm passing the nums list of all these numbers into this function using the map function. So while using map function, suppose I don't have a function, but I still want to execute a function on a particular list of numbers. So I can use the lambda function where and then use this as a function and pass this into this. So this is how lambda functions are useful. They're very easy to declare, and it is just a one line job where you use lambda as the keyword, and whichever you want to pass, you can pass how many ever arguments, but it will give you only one expression. So num2 and num3, and whatever you want to return will be post the colon. So this is how it is, and then you can print y. Also you can pass arguments by adding another bracket and passing it using commas. So this is how lambda functions are used. Now let us look at a few programs with lambda functions. So I'll be doing these programs, and you can do lambda with recursion and printing of greater or smaller of two numbers with lambda functions by yourself. Let me do this, creating a lambda function that accepts a number and returns a new number based on this logic. If the given value is less than 10, uh, then return by multiplying it by 2, else if it is between 10 to 20, return it by multiplying uh, by 3. Let me do that. So let me say convert is equal to lambda x colon x star 2 if x is less than 10, else x star 3 if x less than 20, else x print convert 5 to, and let me call this by saying convert 5. Into, and you can say you can see that we've got 10 here. Similarly, you can execute it for other cases. Let's say 13 and for 23. For 13 we get 39, and for 23 we get 69. Second program is check if a number is even or odd using lambda. Let us execute that. I will say check equal to lambda num. We're passing num, and it should print num comma is even if num percentage, I mean the modulo, is equal to 0, else print num is odd. Let us take the input from user, but I'll restrict it to integer, and we can ask the user to enter a number, and I'll check the number by passing 2 is even, 20 is even, 23 is odd, and 23 is none as well. It is returning none because that is how we have written the lambda function over here. We are saying if it is even, it is going to return even, and it is also going to print num, but so that is why it is printing 23 none as well. The next program is a GCD program, which is lambda's recursion. So recursion of lambda. Let us say greatest common divisor is equal to lambda a comma b, and if b is equal to 0, we have to write it as a if b is equal to 0, because that is how we'll write the functions here. And then GCD a percentage b. So we are calling the function again here by passing b and a percentage b, the remainder of a and b. Now let us say 36 and 6, it gives me 6. Let me pass 36 and 12, it gives me 12. Let me pass 32 and 12, it gives me 4. So this is how the GCD program is working. You can try out the lambda with recursion, because we had done it in the functions, where we had written the factorial program with recursion using functions. You can try the same with lambda, and you can also try printing the greater or smaller of two numbers, where if you pass two numbers using the lambda function, you are supposed to identify which is greater and it should be printed. So this is it for lambda functions. Lambda functions is just a small anonymous function. Uh, it can take any number of arguments, but it can give you only one expression as the output. So this is how lambda functions can be written. Uh, they are written only in one line, where the lambda keyword is used, and whatever is passed into the function is written towards the left of colon, and whatever is the output is written towards the right of colon, and this is assigned to a variable, and if we want to print that variable, we say print x, and we pass the values which we want to pass into this lambda function by using parentheses and entering the numbers beside it. So this is how we use lambda functions. Overall, they are just small functions used. We can use them later when we use maps, filters, and sortings. So these are kind of functions which give you the feel of function. So that is why we use them. So they can be used while filtering, manipulating, and many times where we want just a small code to be executed, which is just one, which is independent, which is a function, but which is just executed once. So we can use lambda functions that time instead of using functions. That's how that's about lambda.